Hi, my name is Ken Lasseson. I wrote and maintain the Microbiome prescription website. What I want to do today is go and look at the latest addition to the site, which I have high expectations of being helpful to a lot of people, especially people where the root cause of a condition is fuzzy or unknown. And the talk is called Looking Beyond Bacteria, an Exploration of the Microbiome Economy. And by that I mean we have the microbiome, all the bacteria are like a city. And we can start looking at specific bacteria, people who live a particular street address, or we can look at what the economy of a city is, what is being sold and bought, what is being delivered, what's being dumped into the sewer, what's being pushed into the air, what's being shipped out on trucks. Given those two things, which is probably better to reflect the health of a city? Looking at individual people on a particular street picked at random, or the economy of the city? Generally, I would prefer to know what the economy of the city is, because the economy will impact individual people, and that's probably I'll go for having a healthy city or a healthy microbiome. So that's the goal of what we are going to be talking about today. Now, to get people to understand a little bit better of my thinking of what I'm doing, is let's look at Cyborg, the small intestinal bacterial overgrowth. And on the screen here, I have how on the Mayo Clinic writes on their websites how Cyborg is detected. Basically, it's a non-invasive breath test, which is checking for hydrogen or methane, which are end products of bacteria, or taking some of the intestinal fluids and trying to culture it. Here's where the gotcha comes for the second way. We can only culture a small subset of bacteria. Many of them will not survive the moment you take them out of a oxygen deprived atmosphere like in the stomach. So the result is, yes, you can culture it, but you are going to be having a limited sample of the bacteria which are actually there, and you may well not be detecting any bacteria known to have the problem, or produce the gases which you can detect for hydrogen or methane. It's sort of like I'm saying, okay, let's go and in 1920 it gets public opinion and we'll do it by telephoning people. Oh, wait a minute, in 1920 only the rich had telephones, which means that the result of your survey is going to be very biased because it doesn't cover everybody. It's only covering people who can afford to have a telephone. It does not cover the majority of the population. So what if we go and take this existing standard practice of looking at end products or other equivalent things, what is being produced in this city of the microbiome, and see if we can get associations with symptoms or medical conditions like SIBO. So that's what the whole exploration today is. Now, how do we get this information? And getting information with the microbiome is, for anybody who have tried it, a frustrating experience. Fortunately, there is a lovely source of information done on the gene levels, which you have done gene by gene analysis of a horrendous number of bacteria. And from the genes, we can identify all sorts of bits and pieces of the economy of the city. In other words, we can get things and it's accurate, as in the genes indicate that this method happened. May or may not be activated, but we now at least have comprehensive information and consistent information. So what we do is we go to the Kyoto Encyclopedia of Gene and Genomes, and I'll just go and hop over there for a moment. And the Kyoto Encyclopedia of Genes and Genomes is sweet. It gives a tremendous amount of information. It gives things by reacting enzymes, and all of it can be related to specific bacteria species. So you end up getting some lovely detailed information. However, extracting the information is a little bit of a challenge, and it involves a fair amount of effort. So we can go in and we can get information from here and do it. We can go and look at the table of contents, which goes and spells everything out, and look at a particular thing, a virus path, pathogens. You can go in there, infectious bacterial, if you're interested in those. And now we have a list of all the human diseases which are associated with the bacterial things, which particular types of infections are known. And we can go in and we can explore further. So here we have the known bacterial pathogen types. For example, pathogenic E. coli. Should be aware that there are also beneficial E. coli. In fact, most E. coli is beneficial. There's just a small bunch of bad apples out there. Okay, so this is where we're getting our data from. You can go in and explore it. It is extremely well recognized source of information and is used by tons of academic researchers. So from that side, with a little bit of data magic, we end up having something like 419 different modules involved. 6,100 different enzymes are being produced by the bacteria. 3,000 end products. Usually when people talk about end products, they say, oh, well, methane, hydrogen, vitamin B12, this or that, and you end up with, perhaps, if you are real knowledgeable, perhaps you get a list of 2 or 3 dozen, and that's it. Most of the end products being produced, you basically are or have been unaware of, and there's 3,000 of them which is being identified. That's a good number. And here is where the challenge comes. We are now looking at 10,000 different aspects of the bacterial economy. So we have to figure out which ones are associated with what. Which ones are associated with air pollution, with water pollution, are associated with higher life expectancy, with less obese people, with happiness, whatever. So we have to search for all of this data and try identifying what appears to be associated with whatever we are interested in. I'm going to skip the statistics and the science of doing it, and we'll just go to hop on and show what we have or how we can do it. So we have on the site, we have under your sample, we have a group of drop-down choices which shows unusual values. They may be no significant, or they may be significant for these values being outlier. All we are doing is saying, okay, these are unusual values. We don't know what it is, but we know that they are unusual. Often you will get a name which you may never have seen before, and you will say, huh, what in the world is that? And you end up having to go and search the web for information about that and do some reading, and depending on your level of education or your ability to acquire new information, you may be either frustrated or enlightened. Some will lead to very targeted action, for example, using supplements or handpicking specific bacteria. Generally, when you go to handpicking specific bacteria, it's bacteria which you are wanting to reduce, so you have less of them. So it is saying, okay, you may have a overproduction of some particular chemical and you want to reduce it, and there are 4 bacteria which are causing this overgrowth, and you may want to figure out which one of those 4 or all 4 of them you want to try to reduce. So that's it. Now let's hop over and just take a look at this on the website. So on the website, there's changing your microbiome. As you see, we have a fair number of samples here. I'm going to go down to grab the last one. And here we have the outliers. And the old one is marked as obsolete. And the reason was that was done not from the genes involved with bacteria, but from finding articles at random indicating such and such produced such and such. It means the list is incomplete, and frequently it was reporting things at a higher than a species level, at a genus or family, which may be correct, but not every member in the family or genus will actually be producing it. So it's marking as obsolete. It's still there for historical reasons if you're interested. And now you have there, for example, you can go here and do K Project Outliers, and it will go and list things which you are outliers for. And in this case, we have 21 entries, everything on one page. And as you can see, things are color coded. You have a bunch of things which you are low in, some things which you are high in, gives you the percentile ranking, and the count here is if you're dealing with multiple samples at one time, which we'll come back to and take a look at. Most of the stuff there, you're saying, okay, so I'm producing, or this person is, or let's use the word I, producing a lot of ketones, which may be concerned. We have other chemicals there. A lot of the stuff you are probably confused. Now, if you click on that and open it, it will actually go over to KEGG and give whatever information it has there. Often it goes to a page which is effectively Greek to most people. For those who have a suitable background, you probably can find it useful. Let's take a look at ketone and see what comes up for ketone. And we have more information, and generally what I would do is after I found something and hit a page of geek information, I'll type in a word here, a ketone, and what does ketone do in bodies? So it gives some information. We can see that it connected to insulin level, so it could make implications toward diabetes. How the interpretation of it is beyond the scope of my discussion or in this presentation. Well, my scope is limited to what I know how to do well, which is to identify data. So we have the bacteria products outliers there. We can also go down to molecular outlier, and we have only one particular thing here. And again, if you click Q, it'll take over to KEGG and gives you information which again you may or may not be happy having to research. And then we have enzymes outliers, and it gives a list there, and we have 25 here, and it gives a list of which ones are too high or too low against the rest of the population, and gives you your value and gives the there. And in some cases you may be a little high or a little low, and you can basically say, oh, forget it, not significant. But again, everything is sitting there. And the DPH is something which probably may be a bit of interest in. Again, more information there. Here we have a comment, and it gives a whole bunch of additional information there. Again, it gives you information. You have to digest, process, and figure out what to do with the information. And we can also go to bacteria outliers, and it shows you what bacteria groups are out of range. Again, we have a small number, and many of them are low, and I generally would not be too concerned about low if the low range is under 1,000. This one is high, is there, but it is sufficiently close. I would not be concerned about it. And then we have this one, where it's on. This one is something which I should filter out, so it's not significant. Okay, so what we have done is seeing where we can get this information and how this information can lead to technical nerd speak about what the condition is. But you can also then take the term and search on the web for more information. You do have a learning curve. No buts, ands, or ifs. Now, so sometimes we have targeted action, for example, using supplements, which will show up on the end products if it is available as a supplement. There's 6,000 items there. There are not 6,000 supplements available, so only a few may show up there. The other option is hand-picking bacteria. And let's go back and take a look at the page again. And if we go here, and we have hand-picked bacteria here. Let's do something high number right here. You notice this little thing underneath count. If you click that, it will go over to the bacteria involved. Oh, for this particular one, but what we want to do is actually want to go over and do it for, let's go for products. So one of the products is too high, like this particular one. If we click here, we'll go over, and now we have all of the bacteria involved in producing it. And you can, as we've seen on other pages, you can go and hand pick which ones which are there. For example, this particular one is high. If we want to reduce it, that's probably the worst. Another one which is also high is that one. So you can now go and just select that to hand pick bacteria for that sample. And since we're in the very last one, we can, or was it? But it would add it in automatically, and I'll verify that works shortly. So that's how we can go and hand pick bacteria for a particular enzyme, modular, or end product coming from KEGG, which is too high. Too low, we could also hand pick and try to improve it. But remember, we are talking about hundreds of bacteria often, which means it becomes a little bit of a challenge. Let's go up here and look up end products here. KEGG end products. And what we have here is we have all of the joyous items. For example, if we were looking at something like Cyborg, which is partially annotated, we'll find, Cyborg. We'll find what's connected with Cyborg, which is hydrogen and methane. And how many methane producing bacteria do we have? 1,500 of them. Now, the other pages only will show the ones which you have reported in your sample, which partially depends on the lab. But what it does do is, instead of seeing list of 1,500 with 0, 0, 0, 0, 0, 0, or 0 unknown because the lab doesn't report on it. And one problem is labs usually only report on things they find, not on things they don't find. So we end up there. We also see that only 2 enzymes are involved in producing it. Hydrogen on the other side, do we have lots and lots and lots of bacteria producing hydrogen and lots of enzymes involved in the production of hydrogen. So that is a whole different challenge. So what we have here is we have ability to understand better where, for example, high methane is coming from. And we'll see in the outliers whether or not it shows up. So question is, does it show up on your sample? Okay, and let's go here, and now we have, wherever we want to be, under symptoms, you see symptoms predicted. Key thing, what does it go through and indicates what are probable symptoms based on a lot of data science, a lot of calculations, computing stuff. I think literally millions, probably almost billions, to indicate what is likely. So you go in here and it will do things, and right now it goes through, and for taxonomy it found nothing which actually was significant. However, when we go down to end product, we end up with a list of things with the percentage match for the pattern, and enzymes, we end up also with that. You see celiac disease, suppression, depression, stress. Although we're looking at a different combination of things, we end up having some overlap between the end products and the enzymes. And if you go down to the KEGG module, you only find one thing. Generally, end products tends to produce more matches, which may or may not match exactly. And remember, these are matches not by causality, but by associations. You can have associations with several symptoms or medical conditions with the same pattern, which just doesn't mean that you will have this condition. It means that you should be aware that there's a possibility that this is part of your symptomology or whatever. So, for example, if you have racing hearts, you can click through here, and now you can go over and see which bacteria are involved, what the odds are of that, just one being critical, and you can again hand pick the items which are of interest. Here we also have the end products showing up, and the KEGG modulars and the KEGG enzyme. But what we have is we have just one particular thing, and we see what the cross product is, what the profile is across everything, and we can, as in this case, we can identify items which we may want to change. Notice the checkbox only shows up for items which are unmatched to the known pattern, and things that are not a match, sorry, you don't get a check mark. And generally you want things with the highest odds, like 1 in 221, which indicates that it is higher than, atypically higher is the likely cause. So you could do that and go down to the bottom, add to hand pick, and that sends you back here, and wherever we are, right there we are, hand pick bacteria, or whichever one we are all on. And now we can go and do the hand pick bacteria, and there we are, and we can add more to it and then get suggestions based on that of the hand pick bacteria. Okay, so let's go and move that aside again. So for predictive symptoms, we end up with a complicated pattern match. Not just one bacteria or one particular thing is up. It ends up having to be a very significant stack of them, which matches the pattern, and the degree of pattern match is there. For example, here we have 100, which means for everything in our pattern, we have a match. So it's a strong match. Other things, we have a significant amount of match. You can adjust the pattern match in terms of how accurate you want to. Default is 0.95. You can raise it up higher if you want, but 0.95 gives you a reasonable number of items usually to take a look at. If you get absolutely nothing, you could drop the level. We do also have support for multiple samples, which is if you have a bunch of different samples and you want to see what is in common across all of them, you can do that. So if you have conditions going on for 3 months, you have 5 samples, and then you have before and after, you can take a look and see how they compare to each other. So for that one, let's go back to the page, and I'll go back to samples. It sits up there, multiple samples comparison, and you can see all of the items there. As you see, there's a whole stack of them, and you can be busy checking or unchecking. I'm just going to do I wish I shouldn't do it, but I'm going to do it for cake products outliers. Remember, for cake products and enzyme, we're talking about thousands of items. I don't want a report with thousands of items about it. I only want things which are significant. So we're just going to do cake product outliers. And there we can see it, and we can visually inspect the pattern and see whatever. Now on the far right, in this case, because we have so many items on the list, we can go to the far right and see there, and actually, because of so many items, I can, oops, that was supposed to be searchable somewhere in there. I mean, sortable is what I was going to say. Okay, something is wrong, but I could take a look and say, okay, 12 is frequently there, show up. Here's number one with 12. 12 is, I think there's 12 samples or something like that. So it means that, oh, not 12 samples, but a significant numbers of it. So we can go in and then scan to the right and see what do we have. Again, we have fancy chemical names and have the joys of doing it. And okay, and we have 62 pages. Okay, ta-da! Just took a little while because it's a big report, 62 pages of them, which is absolutely massive. And I do click that and double try. We have 17 here for low risk and only 8 for high risk. So in terms of that, we have one item which we have 17 items across after sorting it, and we can go down and take a look, and from there go off in the wonderful world of learning about biochemistry and do it. So that's basically how we can get the information. Again, I must apologize. I only can take you to finding the information. Interpreting it is up to your medical professional or your own self-learning to be able to work with it. Summary: the purpose of this edition is to discover associations. Just like with Cyborg, the association is with methane and with hydrogen in the breath. We're doing the same approach. Its approach is being done. We just happen to be doing not just for two substances, but over 10,000. And we are doing it because we're making use of gene level information and the population of how many a particular bacteria strains are there. Everything is working from the strain level, which is sweet. Reminder: association does not prove causality. We don't know that this causes it, or is a shift caused by the condition. We can speculate one way or the other. What we do find repeatedly in studies is that the association reflects the severity of the symptoms. The worse it is, the worse the dysfunction is, the worse the symptoms are. So it's not causality, but it is positive correlation or negative correlation depending on which way the shifts are. In general, I should remind people that generally I'm finding there's not strong matches to studies done on bacteria associated with medical conditions from the National Library of Medicine database, which did surprise me a bit originally because I would assume that there would be reproducibility of results. It turns out it's not, and actually the reason probably is its association is with end products or the enzymes, and that now it's not a matter of 1 or 2 bacteria, but 1,500 bacteria has to be taken into perspective, and they did not go to that depth of measuring. And more importantly, person A with the condition and person B with the condition could have different mixtures of those 1,500 bacteria, which means if you're looking at the bacteria, you get, nothing significant. What it does do is gives you leads to explore. It doesn't give you can answer. It may give you a headache with how much you have to learn, but it gives you a mechanism, a direction to go on and to try doing it. The site will be annotated with supplements where supplements are known, and my QA person is working on producing that list of information for me. So the site will be having more information, like for example when I type in the word Cyborg, voila, we have all of the things. So I'll be adding in more information to help with the search as time goes on. We just got this part up this week literally. So you now have more tools to play with, you have more learning to do. And have fun, take care, keep in touch.